Okay, we have a jam-packed day, examples 6, 7, 8, and 9. We're going to continue on our first derivative test. So find the coordinates of the local extrema of this function. So right now, the only way we know how to do that would be to take the derivative. So let's go ahead and start that. G prime of x equals 30 x to the 4th plus 4 times 33. I think that's 132. X cubed minus 90 x squared. Alright, so there's our first derivative. So let's figure out where that equals 0 because it's not undefined anywhere. And I think we could factor out 6x squared. Alright, so we get 5x squared plus 22x minus 15. Alright, and I believe that can be factored. So we get 5x minus 3 and x plus 5. Yep, that should work out. Alright, so this gives us critical values at x equals 0, x equals 3/5, and at x equals -5. So let's put them on our little sign chart. G prime. Alright, so we have -5, 0, and 3/5, and we have to pick numbers in between them. Alright, and let's see, we could go with 1's always an easy one, maybe 1/5, -1, -6, -10, it doesn't really matter. So you pick those x values out. If we plug them into our factored form, it's a little bit easier. So we plug in a -6. This will be positive. Okay, this part will be negative, and this part will be negative. So if we multiply those out, we'll get a positive number. Alright, here we get positive. We would get a negative number, and then we get a positive number. So this one's going to be negative. Alright, 1/5 positive. That'll be negative, and this will be positive. So we have another negative value there, and plug in 1, we get positive, positive, and positive. Alright, so if we analyze that, so remember, if you want to think, if we were going to draw a graph of just a quick little sketch of g, what we're saying is that the function's increasing until -5, then it decreases, okay, and then it continues decreasing, and then it increases again. So we're going to have a relative max and a relative min here. So we can say since g prime changes from positive to negative at x equals -5, g has a relative maximum value at x equals -5. And I know it seems like a lot, but you have to write all of these things out. Alright, you have to include it. This sign chart isn't enough. You have to specifically say what's happening. Alright, and also, since g prime changes from negative to positive, negative to positive at x equals 3/5, g has a relative minimum value at x equals 3/5. Alright, and that's all, because all we had to find was the x coordinates of the local extrema. If we had to find the actual values, we would just take those x values and plug them in. Alright, so we have example 7 now. Find the relative extrema of this function and justify. Alright, so we're getting pretty good at derivatives, so we'll just go for that. So we get 2/3 times x squared minus 4. Subtract 1 from the power. And don't forget to multiply by the derivative of the inside. Alright, if we make this look a little bit better, we could get on the numerator 4x, and in the denominator we'll get 3, and we can just write it as cube root of x squared minus 4. Alright, so where will our derivative equal 0 at? Only when the top equals 0. So that will give us a point of x equals 0. So that's a possible critical value. And where would our derivative be undefined? Well, that's going to be where the denominator this time equals 0. So we could divide by 3 and cube it. So that'll be x equals plus or minus 2. Alright, so our possible critical values are these. So we'll go ahead and make our sign chart. We have x and we have f prime. So we have -2, 0, and 2. We need to pick some nice values in between. How about 1, 3, -1, -3? Alright, and then we just have to go ahead and analyze them. So we plug in -3, the top will be negative, and the bottom will be positive. And in fact, for most values bigger than 2, the bottom will be positive. All right, so we end up with a negative value there. Negative over, and this will give us 1 minus 4, so that'll be -3. This bottom part will be negative. So we have a negative over a negative, or a positive. Here we have positive over. If you plug it in, you're going to get a negative on the bottom. And then the last one, if we plug in a +3, we get positive and positive. So it looks like we have a couple of local mins and maxes. So we can shorten it up a little. We can just write the sentences with the local mins and the local max. All right, so F has a local min at x equals -2 and x equals 2. Let's just include it in 1. All right, since f prime changes from negative to positive at x equals 2 and -2, and f has a local max at x equals 0, since f prime changes from positive to negative at x equals 0. All right, so we're moving right along here. Let's go to the next page. All right, find the relative extrema of these two functions, just the x-coordinates of them. And so we begin with part A. So t prime of k, let's see, if we rewrite this, it could be k to the 2/3. That might make it easier to take the derivative. So we get 2/3, whoops, come on, 2/3 k to the -1/3 times 2k minus 1, whoops. And don't forget to do the opposite way as well, k to the 2/3 times the derivative of this one. Oh, that would just be times 2. All right, so with our product rule here, we should maybe factor out least powers. It's a really helpful way to analyze functions. So I believe we could take out a 2k to the -1/3. And let's see what would be left over. Well, we would have here 1/3 times 2k minus 1. And on this side, so -1/3 plus what gives us 2/3, and that's just going to be k. All right, we can distribute this out a little bit, so we get 2. This will give us 2/3 k minus 1/3 plus k all over cube root of k. One more step here, 2/3 k plus k, so that's 3/3, that gives us 5/3 k minus 1/3. Alright, let's take a look at our critical values now. So critical values are going to occur when this is 0. Alright, so if I just do this on the side, where is that equal to 0? 5/3 k. Where's that equal to 1/3? Multiply both sides by 3 if you want. So we get 5k equals 1. So we have a critical value at k equals 1/5. Also, our derivative is going to be undefined when k is 0. So let's add these to our sign chart. So we have 0, we have 1/5. These are our x values, and this is t prime. So we could pick maybe like 1/10. That would be fine. You know that's in between there. 1 and -1. Determine the signs. So if we plug in a -1 on the bottom, we're going to get a negative. If we plug in a -1 on the top, we're going to get another negative. So this should end up being a positive value on the left side of 0. 1/10, that's going to be positive up here. This ends up also being, actually, I just need to write this out. Can't think. All right. So 5/3 times 1/10 minus 1/3. There we go. All right. So that ends up being 1/6 minus 1/3. So that'll be a negative value. So negative over a positive is a negative. And then if we plug in 1, positive, positive, end up with a positive. Okay, so we have the x-coordinates of our relative extrema here. We have t has a relative max, x equals 0. Okay, because it's going increasing to decreasing. Since t prime changes from from positive to negative at x equals 0. And you know the same reason there, this will be negative to positive, so t has a relative minimum at x equals 1/5. Oh, come on. Alright, so part B, I believe this is something you could do. We could go over it in class, but I want you to try. It's better if you try on your own a little bit. Alright, and then also example 9. Now in your whisk, I want you to just write for part B where J has a relative min. Alright, so you're going to write that J has a relative min at, okay, and tell me why. And then also on example 9, whoops, I'd like you to tell me this one, F has a relative max at, and tell me why. All right.